than or equal to 10, print of I, and increment the value of I plus is equal to 1. So that's our function which will display all the numbers from 0 to 10. Now to spawn this function off as a thread, define an object T is equal to thread class. To the constructor of the thread class, while we create the thread object, we pass in the target. Target is equal to the function name, display numbers. Just the function name, there are no brackets at the end of it like the function invocation. The thread class knows how to invoke this function and spawn off a thread of its own. Now to start this thread, you will use t.start is the method. That's when the thread will be spawned off. Right click, do a run as Python run, and you will see all the numbers from 0 to 10. But the key here is that now this thread is no longer a main thread. The output that you see here is not from the main thread. It's from a thread of its own. We are creating a new thread from the main thread. In the previous lecture, you have created your first thread using a function. Just to showcase the difference between the main thread and a new thread we have spawned off, you can print the thread names using the current thread. This current thread is available from the threading. Since we have imported star, we can directly access it. Current thread dot get name. Copy that line and paste it inside the function just before the while loop. Save it. Now when this print statement is executed, this is where our program execution is going to begin. Right here, it is still the main thread. Once we spawn off a thread by using t.start, that is when a new thread starts. So let's see what the output is. Run as Python run. If you scroll up, so it says main thread, that is coming from this print here, and thread-1 is being created by the Python interpreter at runtime for the thread we have spawned off. Similarly, if you spawn off more threads, then you will see thread 2, 3, etc. In this lecture, you will learn how to create a thread by subclassing the superclass called thread. So you're going to extend a superclass called thread and override the run method inside it. Right click, create a new file, call it using superclass or using subclass .py. The first line, as always, is from threading import star or just the thread. All we need is the thread from which we are going to extend. Class my thread within brackets thread. So we are extending the thread class and we need to override a method called the run method, which is present on the thread class. So thread.run self, instead of that, here we can implement our own logic. You can grab the logic from the previous script you have created, the display numbers. You can paste that logic right inside the run method. Make sure the indentation is correct. Everything should be under the run method. This should go under the while. And that's our logic. You can get rid of this line. We don't need to print that. You already know. The I is equal to 0 should have proper indentation. And so is the while. There we go. So we have defined a class called myThread, which extends thread, and we are overriding the run method from the parent class. And now let's create the instance of our own thread. T is equal to myThread, which is an object of our class. To run it, T dot not run but start. You need to invoke the start method, which is available on the thread class. Internally, it will spawn off a new thread and invoke the run method that we have overridden. So always remember, do not directly call the run method. If you do that, a new thread will not be spawned. It will be run as a part of the main thread. You have to invoke the start method. That is when internally the thread class knows how to spawn off a thread and invoke the run method. Right click, run as Python run, and the output is 0 to 10, but you have created a thread by deriving or inheriting from the thread class. The last method to create a thread is to use a class which does not inherit the thread class. Create a new file, call it using class.py. The first line, as always, is from threading, import star. Create a class, call it myThread, but this time our class will not extend the parent class thread. Instead, we are going to directly define a function inside it. You can grab that function by going to the using function.py, copy this, come back using class, paste it, get the indentation right, and also there is a small change that should be made to the display method signature. The display numbers needs self because all the class methods need access to the self as a parameter. So that's good. So we have defined a class with a function inside it. Now to spawn this display numbers as a thread of its own, we'll do it similar to how you have done it when you created a thread using a function. But first we need to create an object of this class. So call it obj is equal to myThread. So we have an object of our class. The next step is to create a thread object using the thread class and pass it the target. Target is equal to obj dot display numbers and no brackets at the end. The thread class knows how to invoke this method while spawning off a new thread. And to start the thread, you need to use t.start. Right click, run as Python run, and the output is still the same. As you can see from this print statement here, a new thread 1 is spawned off. So to create a thread without subclassing, you simply create a class, define a method, and you create an instance of that class, pass that instance dot the method name you want to spawn off as a thread to the thread object using the target parameter. And then you invoke t.start. You have learned the different ways in which you can create threads, but you are yet to use multi-threading. We have been creating a single thread. Instead, you can easily make this a multi-threaded application by copying these two lines, paste them a couple of times, change the second one to T2 and the third one to T3. Now we have three different threads that can run and execute the same logic here. Right click, do a run as Python run, and you can see in the output that there is thread 1, thread 2 and thread 3. The scheduling of these three threads is up to the Python thread scheduler. As you can see, the thread 1, it prints the numbers from 0 to 4 and then thread 2 starts off. So it depends on the Python thread scheduler how the scheduling happens, but all of them will do their work at the end. If you rerun the program, the output could be totally different. As you can see, now everything happens in a sequence. Thread 1 finishes its work, then thread 2 and then thread 3. So it's totally up to the Python thread scheduler on scheduling the threads. But you have finally seen multi-threading in action. In this lecture, you will learn how to use the sleep method that you have learned earlier from the time module to push a thread that is currently running into sleep mode. So right before this while here, use sleep from time. Once you click that, automatically that import will be added. From the time module, we are importing sleep function and pass in seconds, say 1 second. So the first thread will come into this method. It will execute this, it will execute this, then it will go into sleep for a second. Same with the second thread and same with the third thread. Let's see the output by running the program. As you can see, thread 1, thread 2, thread 3. So as soon as thread 1 comes in, it prints that line right here. That's what is happening. Then it goes into sleep. Thread 2 starts, but again that is pushed into sleep once that print happens. Thread 3 starts, it will go into sleep as well. Then again thread 1 will start executing, prints all the numbers. Thread 2 will print all the numbers and thread 3 will print all the numbers. So you can use sleep to push a thread into sleep for how many seconds you want. the other threads will continue, but once they hit sleep, again they will go into sleep, the next thread will continue and so on. In this lecture, I will work on one more multi-threaded use case, which is book my bus. This will allow the end user to buy their bus tickets. It's a very simple application again. You can implement it using either of the approaches, either subclassing a parent class called thread or simply using a function or using a class that does not extend a thread. I'm going to follow the last approach, which is to create a class. So right click, create a new file, call it bookmybus.py. The first line is to do the import from threading import star for now. The first line is to create a class called bookmybus, and within the class it will have a single method buy. This is where we can implement all the logic to buy a ticket. Simply add some print statements. Print confirming a seat. That is the first thing that should be done. The second thing is processing the payment, and the last thing could be printing the ticket or emailing the ticket. Say printing the ticket. So a very simple buy method. Let's spawn off multiple threads. To spawn off a thread, T1 is equal to thread. The first parameter is the target is equal to, you need to create an object of bookmybus. So start doing that. Bookmybus obj is equal to bookmybus. You don't need bookmybus on the left hand side. If you are working with Python, bookmybus, and here obj dot buy is the method. That's the first thread. Let's create two more at least. T2, T3, invoke T1 dot start. Similarly T2 dot start, and finally T3 dot start as well. Save it, right click, run as Python run, and you see confirming a seat, processing the payment, printing a ticket. So each of the threads does all the three things. When multiple threads are accessing the same resources, it is very important that they don't corrupt each other's resources or objects. For example, in the flight reservation, ticket reservation or movie ticket booking, whatever tickets or seats that are being booked, if we have multiple threads, one thread blocking the seats, another thread making the payments, and another thread taking care of emailing the tickets, we do not want these threads to corrupt the same available object, which are the seats or the tickets. That is, the end user should never end up, two different end users should not ever end up buying the same tickets or same seats. That is where thread synchronization comes in. We can lock an object for a particular thread using two different ways, using locks or semaphores. When you lock an object, when a thread locks an object, it enters into a room of its own. It will take that object and it will own that object, and only when that thread releases that object, the other threads can use that object or resource. This process of thread acquiring a lock and entering a room is also known as thread mutex. To acquire a lock on an object, first we need to create a lock object and invoke l.acquire. So the thread will acquire a lock on the current object if you invoke the acquire method like this. Once it acquires the lock, until it invokes the release method, no other thread can process or use the current object. So this is lock. Similarly, we can also use semaphore. Semaphore is simply acquiring a lock, but internally it uses a counter. Internally, initially, there will be a number 1, and every time a lock is acquired, this number will be decremented by 1, which will be 0. And then once the lock is released, that is incremented by 1 again. So the internal implementation is different. To acquire a lock or to use semaphores, you create a semaphore object Everything else remains the same. You will acquire the lock, you will then release the lock. In this lecture, you will add some logic to the bookMyBus by method, and in the process you will learn how to pass parameters to the function that we are invoking when we are spawning it off as a thread. Here when we spawn these as a thread, we don't need to specify this parenthesis. Just need to provide the object dot the method name that should be invoked. So let's implement some logic here. Let's start with the total number of seats that are available on the bus. We are going to initialize that right when the object is created. Def underscore underscore init self dot available seats is equal to, we'll pass that in as a parameter when we create the object so that we can initialize it. Available seats is the parameter. Assign that to the self dot available seats. Go to the by method, and here now we will do this ticket processing conditionally only if the available seats are more than what the user is requesting. So this method, by method, will take a parameter which is seats requested. So when the user is purchasing, the client is purchasing the tickets, he needs to specify the total number of seats he wants. And here we'll do a check if self dot available seats is greater than or equal to the seats that are requested, colon, then all this processing here should happen. So do the indentation so that it goes under the if. And once we execute the confirmation of the seat, processing the payment, printing the tickets, we need to reduce the available number of seats by subtracting this seats requested from the total number of seats. So self dot available seats minus is equal to the seats that are requested. Else colon, simply add a print statement. Sorry, no seats available. And now we need to pass this parameter when we are spawning this method off as a thread right here inside the thread constructor. The second parameter is args. Args is equal to, within parenthesis, the total number of seats you want. Say 3 seats on the first thread. The first thread is processing a request where the user has requested for 3 seats, but you need to pass in a iterator or a list. This guy here, when the arguments are passed in here, internally the thread class expects this to be a list that can be iterated. So simply add a comma and that will make it a list type or a iterator type. Copy that, paste it on the second guy and the third one. Change the number of seats on the second one to 4. So we are requesting a total of 3 on the first reservation, 4 on the second reservation, and 3 on the second reservation. And the total number of seats available should be passed into the constructor right here. Say 10 to start with. So that will initialize the total number of available seats to 10, and then the requests are made by multiple threads. Right click, do a run as Python run. Let's see what the issue is. Cannot import name args. Let's scroll up, get rid of this import. We don't need that. Args here is already available for us. It's just an attribute. That was an unwanted import. There we go. Confirming a seat, processing the payment, printing the ticket. This is the first thread, then the same for the second thread, and then the third thread. But this time the difference is that we are using the total number of available seats. We have initialized that, and you have also learned how to pass in parameters, and we are using those parameters to deduct it from the total number of available seats. You can add a print statement here. Total seats available, colon, and here self dot available seats. So that every time we run it, we can see the total seats that are available. Initially it is 10. Once the first thread runs, it becomes 7 because 10 minus 3 is 7. Then the next one runs, 7 minus 4 is 3. So when the third thread comes in, the total number of seats that are available are 3. That's the reason you see a proper output. But now if you change the last one to say 4, save it, run it. Now you see that when the last thread comes in, it does not go ahead with the processing of confirming a seat. It goes into the else and it displays sorry, no seats available, because the total seats available are only 3, but we are requesting 4. In this lecture, we will implement synchronization or locking for our Book My Bus application. In this by method, when we have multiple threads accessing this method, it is quite possible that the first thread comes in, it does this if check, and it sees that the seats are available, and it goes in and it's going to confirm the seat, process the payment, etc. And just before the first thread does this reduction of available seats, the second thread can come in into this depending on how the thread scheduler schedules it. It can come in, does this check, and it can see that the seats are still available, and it goes in and it can do the processing even when there are no seats available, because the reduction has not happened. The second thread or the third thread can think that the seats are available, which is not a good thing. We'll end up having multiple passengers with the same tickets in the bus stop, which is not a good thing to deal with. Overbooking is never a good thing. So we can implement synchronization here by locking up this entire code or this method for a particular thread. And to do that, we need a lock. Let's initialize that lock right in the constructor. Self dot L, or you can call it whatever you want, is equal to lock is the object. So lock is a class from the threading module. You create an instance of it, assign it to self so that we can use it inside our by method wherever you want. So right at the beginning of this method, self dot L dot, to acquire a lock, you use acquire is the method, ACQUIRE. That's the method or the function we need to invoke. And at the end of the function, right here after the else, self dot L dot release the lock. So acquire and release are the functions that we should be using. Rerun, and you still see the same same output without any issues. But now we are locking this entire logic for a particular thread. We can also acquire this lock right here just before this if check, and we can release the lock right at the end of the if check. It's up to us. Using a semaphore is super easy. All we need to do is to create a semaphore object instead of a lock. So change this to semaphore, and that's it. Your code will still acquire the lock. Everything else will work as before. When we work on real-time applications which use multiple threads, often these threads need to communicate with each other to get the job done. And a very common pattern we see in multi-threaded applications is the producer and consumer pattern, where we have two threads, the producer thread and the consumer thread. The producer thread is responsible for creating some work. For example, it might be receiving all the orders a customer is placing. It will prepare those orders, the list of products within a particular order from the customer. Assume that we are working on an e-commerce application. We have a producer thread that is responsible for taking the orders from the customer, and the consumer thread is responsible for consuming the orders and shipping them, or processing the orders and shipping them. So these two threads need to communicate with each other, because the consumer thread needs to know when the work is available or when a list of orders are available for processing and shipping. One way to do this communication is to have a flag, a Boolean flag called orders placed on the producer thread. The consumer thread will be continuously checking if this flag is true. Initially, this flag will be false. Only when the producer thread has a list of orders, it will flip this flag to true. And the consumer thread will be continuously checking to see if this flag is true. If it is true, then it will take the list of orders from the producer thread, process them and ship them. So using a Boolean flag is one way of thread communication. In the next few lectures, you will also see other ways of using the thread API to communicate. In this lecture, we will see thread communication in action by using a Boolean flag. So we are going to create two threads, the producer and consumer, and they will communicate using the orders placed Boolean flag. Go to PyDev, go to the multi-threading project, create a new file, call it thread communication using a flag.py. Thread communication using a flag.py. The first step is to import the threading module, import or from threading, import star from time, because we are going to use the sleep method to add some delays, star. Next step is to create a class called producer. This is the class that is responsible for creating the work, which is producing the orders. Define a constructor. Within the constructor, we'll initialize a list, self.products list is equal to an empty list, and self.the Boolean flag called orders placed. Orders placed, you can call this flag whatever you want, give it a meaningful name. Orders placed is equal to, initially this will be false. And the next method is the produce method, which will produce the work. Produce. Within the produce method, we'll loop through, use a range for I in range. Dynamically, I want to add some products, 1, 5 products, colon. Here, we'll use self.list or products. Self.products.append. I'm going to append a product name called product plus I. So here we are using a static string called product plus I'm appending a dynamic integer value to it or an ID to it. So as this loop goes through, product 1, product 2 all the way up to 5 will be added to the products list. And once that is added, we can print. As the process goes on, you can say item added or product added. And we can also add a delay here, sleep of 1 second. So that's our produce method. But the end of the produce method, before we wrap it up, outside the for loop, self dot flip the flag orders placed is equal to true. Now that we have a list of orders ready, we have to flip this flag to true so that the other thread will check for that. Create another class, consumer, and within the consumer define a init method. This init method will take self comma prod or the producer thread. So let's call it prod. Self dot prod is equal to the prod that is passed in. So it needs access to the prod thread to get its job done. So we are passing the prod, we are assigning to a field called prod. Next, define the consume method. In the consumer, consume is a key method. In the consume method, we need to poll. We need to continuously check if this flag is true. So inside the consume method, we'll access the flag using a while loop, while self dot prod dot, which is the producer thread, orders placed. If this is true, then this loop should stop. So we are saying if it is false, continue. Go on with the loop, and inside the loop we can add a delay. Why continuously check? Add a sleep, say 0.2 seconds. So it will wait for 2 seconds and it will again check if this flag is flipped to true. If it is true, it will stop. Here we are checking for false, so it will continue. But whenever it is true, it will come out of the while loop. As soon as it comes out of the while loop, you can say print. Let's add one more line there. Print orders shipped or processed space plus self dot prod dot product. Simply display the list. So here we are saying that we are shipping the orders, or we have shipped the orders, because now the orders are ready. Whenever it comes out of this while loop, that means this flag is flipped